Dear ladies and gentlemen, welcome to this session on Artificial Intelligence and Steelmaking Summit, given by Danieli Automation. My name is Luca Cestari, and I am Digital Transformation Manager in Digi&Met. And today, we will talk about how artificial intelligence can simplify steelmaking complexity. In the agenda of this session, we have a brief introduction about us. Then we will speak about industrial Internet of Things platforms dedicated to machine learning operations. Then we will describe a specific use case on bar counting in a rolling mill. But first, let me spend a few words about us. Danieli Automation is a company with over 50 years of experience and more than 400 plants operating worldwide. Our mission is to provide process automation and control systems for the metal industry, covering all the spectrum of Danieli technology. Danieli has recently created a new cross-functional business unit named Digi&Met, whose mission consists in developing and implementing new plant design concepts based on digital innovation and also new business models based on servitization. Digi&Met vision can be summarized by the statement from a plant to a smart plant, which is a plant based on the extensive digitalization of the process. This can be achieved by applying on different business domains, such as production, quality, or energy, a data-driven approach, which aim is to apply innovative digital technologies, such as machine learning and artificial intelligence, to extract knowledge from data for supply chain optimization or technological process enhancement. This data-driven approach requires different steps, from a preliminary analysis of the business targets, then collection of data, aggregation, validation, integration, and then the actual development of a machine learning or a predictive application to transform the information into knowledge that can be actionable. We have several proof of concept POC projects that we carried out in the last years that prove the feasibility and the added value of this concept in the steelmaking, with implementation of models and algorithms based on statistical methods or deep neural networks, depending on the context. Then, when the POC is over and the benefit of the model is proved, then it is time to move it to production to get the real value out of it by integrating the AI application into the daily workflow. And this is exactly where an industrial solution is needed, just like ours. The capability to build a solid, extensible, and secure infrastructure to host machine learning use cases is commonly seen as one of the biggest challenges to face in order to translate the results of the demo or the POC project into robust and long-lasting solutions. Traditional architectures, like those based on conventional industrial automation stack, typically fail to provide this efficient management, especially of the big data streams and the repository with the desired performances, and also are not fully ready to exploit the full potential of AI technologies. This is why also in Danieli Automation, we worked on the implementation of a custom IoT platform dedicated to the metals business that is based on a solid infrastructure with good characteristics in terms of flexibility, scalability, and security, able to work in the cloud as on the premise. Q3 platform, that is the name of our platform, is an industrial IoT platform specifically designed to normalize data stream collection and management from every field application and to unify it into a single scalable data elaboration and storage tool. Theoretically, every technological component in the platform can be either kept on the cloud or on the premise. For most cases, however, the solution that ensures the most efficient performances in terms of scalability, security, disaster recovery, and savings is the hybrid approach, with some components kept on the edge and some others placed on the cloud. Thanks to this architecture, it's then possible to use the same technological infrastructure as the basis for implementation of different solutions for different domains like quality, maintenance, or energy, taking advantage of common data handling and analytics features and a unified web interface. The architecture of the solution is designed to integrate data acquisition from many sources, such as level 1, level 2, PLC, MES, smart sensors, and so on, connecting Danieli or third-party automation and IT protocols. Then inside the platform, we have several technological components and modules that allow to integrate, transform, store, and visualize data in a common web portal, virtually from any size or width or type of data coming from any potential source. And by means of data extraction and loading scripts, data are readily available to implement statistical analytics, quick predictive POC projects, as well as complex deep learning solutions. The basis for the full industrialization of a digital AI project is the availability of a dedicated MLOps workflow. MLOps stands for ML operations, just like DevOps stands for development and operations in the common software development procedures. MLOps is a module that we have developed inside the platform to manage AI projects, and it's well integrated into the rest of the framework and the platform, sharing data workflow and user experience. MLOps allows to handle all the steps in a typical AI or data science project, just like the project definition, coding, versioning, build and training, testing, up to the deploy, which means making the forecast available to all the applications of the person involved in the project in real time or in batch. Now, after an overview on the architecture, let's speak about a concrete use case where this approach and this architecture have been used.
Simplifying metals complexity and improving plant efficiency, reducing time losses, production stops, and eliminating the encumbrances for inline installations. These are the main challenges of the steel market. How to deal with them? Danieli Automation can support you in adopting an AI solution to improve the performance of your plant with Don Counter, an accurate bar counting system that uses artificial intelligence to improve plant automation. It is an off-the-shelf product for the needs of your steel plant, all-in-one and easy to assemble, dust, water, and high-temperature resistant. With Don Counter, you don't need an invasive installation, reducing downtimes and improving the efficiency of your plant. It is also natively integrated with level 1 and 2 for setting the number of bars per bundle. The real-time counting system gives an accuracy at the higher frame rate available, powered by NVIDIA technologies. An integrated separation equipment is activated depending on the objective number of bars counted. With Don Counter, you can obtain above 99.99% counting precision, self-diagnosis system, and enabling the user in the pulpit to see exactly what the camera sees. AI in metals, the knowledge of Danieli and BeyondTech together for your plant efficiency.
The request from the market is to be able to sell bundles based on a quantity of bars counted in a reliable way. And existing solutions for this task typically use the invasive mechanical installation that guarantee this precision. Today, we can simply look at the bars and count them very simply and with high accuracy, relying just on a camera and some artificial intelligence algorithm. And this is why Danieli, together with our technological partner BeyondTech, designed Don Counter, combining AI and machine vision techniques with our domain know-how and our automation and mechanical competence. The final scope then is to precisely guide via software each single phase of counting and separation process of the bar in the fast and finest way. Desirable features for this kind of product are to be something that is off the shelf for the needs of any bar mill, all-in-one, easy to assemble, resistant to dust, water, high temperature, and also that can be natively integrated with level 1 and level 2 automation systems for setting the target number of bars to be put in a bundle. The principal operation, well, it's quite simple. We have an optical device that is used to detect, identify, count, track the head of the bars from the incoming layer. Then combination algorithms that provide the tracking of the bars and a mechanical separation unit that splits the bar according to desired preset number. The cycle starts with counting. We have the bars coming from the chain transfer that pass in front of the camera. Camera starts to count them till reaching the preset number that is assigned at the beginning of the campaign. When the number of bars that has been established to keep in the final bundle is achieved, then the chain transfer stops thanks to a signal coming from the counter, and the pre-separation arm starts the seeking cycle. Scope of this phase is to separate the head of the last counted bar from the following head of the uncounted one and create the useful space required in between. Then we have the separation unit that start raising the arms to finally get the division of the whole layer length. When the separation cycle is over, everything restarts with the normal operating sequence. From the technological point of view, the core of the product is the optical device, which handles the real-time acquisition and processing of the high-speed video frames to count and track the bars and the finger of the separation unit. The optical device is made up of an industrial color camera and optimized lighting setup for image acquisition. The actual mechanical separation of the bars is guaranteed by means of a dedicated device, which handles the splitting process, separating the groups of bars according to the target. The separation device is made up of an horizontal translating curve, a separation finger, which addresses the correct positioning of the target bar, and a separation device unit, which completes the full split of the two groups of bars. The algorithm is based on a hardware solution that is powered by NVIDIA GPU technology to reach the desired performances. The core of the software is on a Danieli automation high-pack proprietary technology for the field elaboration unit with two operating systems, one Windows for the counting, and then we have a real-time OS for control and interaction with IOs and the plant. And data collection for machine learning training, inference, deployment, and monitoring of the algorithm are handled by means of the architecture that we have seen in the first part of this presentation. The processing time guaranteed by neural network and computer vision overall cycle is 20 milliseconds for a frame rate of 50 Hz. And this target is reached thanks to an extreme parallelization of the computing threads that allowed us to keep the overall processing time per each image during counting within the time constraint that we have been given. As you can see from this image, while bars are proceeding, the system keeps track of the target bar for separation and then prepares the finger to split the bars at the right time. This short video shows in detail how the counting procedure works. And then here we have the bar splitting cycle that requires acquiring all the necessary information from the counting process, driving the mechanical splitter to the target, performing the splitting, analyzing the outcome, and then setting up new attempts for stripping if it's needed in order to correct any error that can be made in the previous attempt. So the algorithm is able to understand if pre-separation was correct, so we have a correct full separation, and if it's not, to handle a maximum of 3 attempts to correct the error. If the separation is still not correct after the 3rd attempt, then we have full splitting anyway, but then we have a warning that is recorded to the system. The performances that we got from actual field tests are higher than all the reference literature available. We have achieved counting accuracy higher than 99.99% on 8 and 10 millimeter rebars. And also the separation accuracy is comparable with a very low number of splitting attempts or repetitions. So what are the advantages of this system? Of course, no physical contact with moving product, is not affected by temperature, by surface color, no moving parts. It's very robust also in harder conditions, harsh conditions. And the benefits of the application can also be extended to potentially any product profiles, such as those produced in section mills. So, summarizing, we have seen today an architecture and an application where AI was used in an efficient way to execute tasks automatically, improving plant efficiency. This is, I think, an effective example where digitalization and artificial intelligence can support an easier and simple metals industry. Thank you very much for your attention, and see you soon with more innovation from Danieli Automation and Digi&Met. Bye.